Have you ever noticed that when you're walking along outside and a great big black cloud comes your way, that usually you get wet? Obviously, this is because it rains. And so, what do you do the next time you go outside and you see that the sky is full of big black clouds? You take an umbrella. And even if it does rain, you don't get wet. Noticing the event of dark clouds in the sky and determining that you get wet while being unprotected underneath of those clouds is what we call making a correlation. Anytime that you can predict the outcome of an event, dark clouds, you get wet, you will have a powerful tool simply because you've noticed that two variables move together and which one came first or which one caused the second to occur. When an economist can find two variables that move together, they're very happy because their job is to make models to predict the future, where a model is a simplified version of reality. So what do economists do when they want to develop a model? The first thing they do is they look at real-world observations, think about the relationships that they're seeing, decide on a relationship, plot and study the scatter diagram first, because this helps them determine if a valid model exists. The first type of model is a positive or direct model. In this case, as the x variable increases, the y variable increases. Think about a relationship in your life where one variable causes another to increase as it increases, and draw the scatter diagram on the graph. And so what you should see is a diagram that goes from the lower left to the upper right. It may look something like this. For my example, a positive or direct relationship is between sunny days and happiness. What I find is, as there are more sunny days in a year, the more people are generally happy. This is how we generally see a positive or direct relationship between two variables. We usually draw it as a straight line going from the lower left to the upper right in the first quadrant, or it slopes up. The second type of correlation is the negative or inverse. Here, as the variable on the x-axis increases, the variable on the y-axis decreases. Or the graph goes from the upper left to the lower right. Draw this scatter diagram and label it with two variables that you believe are negatively or inversely correlated. My inversely correlated relationship is between rainy days and happiness. Generally, the more rainy days there are, the less happy people are. And again, we can fit a line to this scatter diagram, and we can see that as the number of rainy days increases, the amount of happiness decreases. We can also say that this curve has got a negative or downward slope. Last, sometimes the data that you gather is unrelated. And so the x-axis variable does not affect the y-axis variable. Try to think of two variables which are unrelated and plot what the scatter diagram would look like. My unrelated graph is going to look like this. The number of rainy days and the amount of money in my pocket. Usually, I have a constant amount of money in my pocket, say $20. Obviously, this unrelated category can have different appearances. You can have a straight line, a vertical line, or you could have, which perhaps some of you put for your own example, a scatter diagram that is scattered. So here we've discussed the different types of correlation between the x variable and the y variable, or the relationship between the independent variable on the x-axis and the dependent variable on the y-axis. One more time. That's the independent variable on the x-axis and the dependent variable on the y-axis. The independent variable causes change in the dependent variable. And that's how you think of correlation, how one variable affects another.